Welcome to all. As I told, the most important class for moment of inertia calculation. This is part 4, and remember, also next is part 5. These two are pure numerical examples. Make a note here to get complete control on moment of inertia calculation using parallel axis theorem. See, written here. Both will give complete understanding or control or knowledge or grip or whatever you want to call for application of parallax theorem. That is what we will be doing later for each and every problem. Now, very critical, you have to go through each and every example, plenty of examples. Single class, if I upload, it will become more than 2 hours, 2.5 hours. So I decided first class is special today. Part 4, I will write part 4, is a special. One rectangle will be there, roaming around. We will place that rectangle in different positions with respect to the two axes here and find moment of inertia. This all you have to write. So first for both part 4 and part 5, 1 minute, make a note here. Some statement you have to write. Consider two axes OX and OY. Class, very important. Right class, right now OX and OY are just randomly given by me, right? Randomly given by him for finding moment of inertia. Means we have to find moment of inertia about OX and OY. Okay, now we will find moment of inertia about OX and OY. That is what? That is, we will find I about OX and I about OY. Okay, now this is first one. But note, again in class, later, this O is going to be G, capital G. See, red color. G means here, when I write here, G stands for centroid for entire cross section. Entire cross section means when cross section consists of multiple parts, multiple rectangle, triangle, rectangle with the semicircle, etc. Whatever is there, when multiple parts are there, this G, capital G, see red color, is centroid for entire cross section, and at that time OX will become your XX axis, OY will become YY axis, see, as shown here, right here, as shown here. Then this will become G, right? G for the entire cross section. Then we will call this as XX axis and YY axis. And this is what we want. This is what we want. This is what we want in our course and also in structural engineering. So later it is going to be. So today I am just writing OX and OY. Okay, now little more statements are there before I go to examples. Anything pending? Nothing. So part 4, part 5 both are same, continuation. I won't tell. When I go to part 5, I will tell. Unless you consider part 4 and understand, don't come to part 5. Okay, now this all I will remove. Little more statements are there. Some will tell, he is giving more and more statements. Yes, statements are more important. Okay, now what we will do is, see, I write here, what we will do in part 4, that is this class. See, we will write here, we will consider the axis OX and OY. O, this is, I write now OX, OY, over. And one rectangle will be there. See, there is a rectangle. See, I write here, there is a rectangle. Say some dimension, any dimension will do. Say, usually width will be lesser. Say 100 mm. Okay, 100 means a round number, not 100 mm. Okay. 75 mm by say half 350 mm. 350 is not required. 75 by 75 by, okay, little bigger I will take. Say 250 mm by 400 mm. Okay, this will do. 250 by 400. That's a rectangle. Where it is there, see, this way. And this 250 mm is horizontal and 400 is vertical. That is, there is a rectangle like this here. See, somewhat to scale. This is a rectangle. This is, when I put later, little bigger I will write here, 250 by 400. 400. Okay. Now, this rectangle, today that's all. Right now, a rectangle. Next, part 5, not rectangle. A right angle triangle will be there. 4 times it will come. Then, isosceles triangle is there. 4 times it will come. Triangle in general, again 4 times. A circle, only once it will come. A semicircle will come 4 times. A quadrant of a circle, again will come 4 times. There is a reason for it. It will come. I will give dimensions later. That is in class, next class, part 5, next class. This rectangle is, you imagine this rectangle is a part or component of cross section or a lamina consisting of multiple parts. You write here. There is a lamina or cross section or area or some area which consists of multiple parts. It can be 3-4 rectangles like I section, or 2 rectangles for T section, 2 rectangles for angle section, then rectangle, triangle for trapezium. So many. Sometimes circle will come, then sometimes semicircle will come, that way. Multiple parts are there. This is one among them. There and now. When we find moment of inertia, right here, when we find moment of inertia, what you do is, we consider each part separately. Therefore, at that time, this part will be component or part. See, that is green color today. I told it is not the entire cross section. And its centroid is today, it is here. See, G, small g. Its area is small a. Total area of the given section is sum of all the areas like this. How many rectangles, triangle, etc. This I told, the centroid for the entire cross section will be capital G. But today, I don't know, randomly. That may be here only later. Right now, you don't bother it. You write all those things. Then, we will bring it here. I will be big sketch here. I will ask it to place here. I will tell the rectangle, you sit here, be here, be here, be here, be here. One quadrant. I won't move all the quadrant. See, not required here. Different possibilities are there. That is, right here, this centroid G orientation with respect to this axis, different possibilities are there. I will discuss all the possibilities and give complete control to you for applying parallel axis theorem. And when I take right angle triangle or other triangles, or only once it will come, I will place somewhere here. But at that time, there is a G for that also. So principle is same. But that, see, sometime this rectangle will cut this area. It will come somewhere here. That can happen for triangle. That all will come later. So next time what I will do is, in part 5, I will put a bunch here. See, so many are there. There you can see 4 right angle triangles, 4 isosceles triangles, 4 triangles in general, 1 circle, 1 semicircle, 4 semicircles, 4 quadrant. I will sit here and call one by one. Come. All of you stand, come and here, somewhere here. That cutting the axis all, I will explain today. Later, it may cut the axis. Important is what? What principle you are using today for rectangle, same thing. For easy understanding, rectangle. And each time I will find moment of inertia about part 5, OX and OY. Later it will be XX and YY. That all very later. So now, this all explanation now. So now, just before going further, I will give last warning for you. How to apply parallax theorem? I may forget it. How much I doubt? See, I forgot. 250 by 400, correct? See, so good in forgetting. I don't know why. 250 by 500. I am so 400. I am so good in forgetting. Now, before I start calculating, what I will do is, finally, lastly, and really lastly, I will give brief application of parallaxis theorem. Parallaxis theorem. It is already told many times. As from parallaxis theorem, parallel axis theorem, I about red color, see, I about any axis. Make a note. It can be OX, it can be OY, it can be XX and YY later. Anything about any axis equal to, I told you, green color. See, IG, moment of inertia, you write here, moment of inertia of the component considered about its own centroidal axis, that is, axis passing through its own centroid, small g, centroid of that component parallel to required axis. If you want I about OX, that centroidal axis should be parallel to OX. If you want I about OY, that centroidal axis should be parallel to OY. If you want I about XX, later, not now, that centroidal axis should be parallel to XX axis. If you want I about YY axis, centroidal axis should be parallel to YY, plus area is the area of the component, you write, into h square, perpendicular distance from centroid of the component, G to required axis, to the axis about which moment of inertia is required. If you want I about OX axis, perpendicular distance from centroid G to OX axis. When the axis is horizontal, distance is vertical. If you are not knowing, I can't do anything now. If you want OY, perpendicular distance from centroid G to OY is vertical, so distance will be horizontal. Yes, now I will not tell parallax theorem again and again. There's a limit for everything. Okay, over. Now I will do one thing. I will start preparing the sketch for application of today's exam. As I told, part 4, we will consider rectangle. I already told 250 by 400. I remember 400. Okay. After some time I will remember. There are many, see, this is a rectangle. There are many cases. 1, 2, 3, 4, 5, 6, I don't know. So, etc. One by one you consider. What statement I am telling you writing? Case 1, class. I will tell you how. See, what I am dictating, you have to write. I can't write in the board. The rectangle is placed so that the center of the rectangle, center, you know what is center? See, exact center. That center itself is centroid. That is later. Center of the rectangle coincides with O, right here. Center of the rectangle coincides with O. Okay, start. See, 250 here, 400 here. Center coincides means 125 this side, 125 this side. Here 400, 200 this side, 200. See, this 200, 120, 125 is not green color. It is not centroid location. It is given in the question. Black color is given in the question. Remember, black is given. Okay, over. Start. by parallax theorem, I about any axis, Ig plus A square. Now I will not explain. See correctly. I about OX axis. What you do? First mark centroid. Oh, right here. See, whatever is the centroid of this cross section, see, this is G. The centroid G will correctly coincide with O. So this is G will coincide with O. Therefore, now start. I about OX. Come to centroid. See, first what I told. First consider rectangle. Axis passing through centroid and parallel to required axis. This is X and Y. This is Y and X. I forgot right here. This is your Y and X. Okay. This is your Y and this is X. Okay. Axis passing through centroid and parallel to OX is exactly this axis. This, see, same axis. 250 into 400 cube by 12. This I will not explain now. This is already told for you earlier. Parallel side into perpendicular side cube by 12 plus area 250 by 400 into perpendicular distance from centroid of the component to OX axis. Centroid of the component lies in OX axis. So see, when the axis is horizontal, vertical distance. There is no vertical distance. Why? It coincides. Therefore, 0 square. Answer is not required. This is Ig plus AH square. See, in the order, this is Ig, this is A, small area of the component A into H square. This is H square. Okay, start. I about OY. Come to centroid. Axis passing to centroid and parallel to OY is exactly this axis, same axis. 400 into 250 cube by 12, Ig. Area is clear. There I wrote area 250 by 400. Here since 400 came first, I put 400 by 250. That is my wish. Into distance square from centroid of the component to the required axis. Centroid of the component lies in the required axis, or vertical axis means horizontal distance. From here, no distance, 0 square. Okay. Case 1 is over. Now see. Second case. Second question. Every question I am dictating in the class. See. I will do one thing now. Here, these 4 corners, I will give name A, B, C, D. These 4 corners, I will give name A, B, C, D. Okay. There is a reason for it. Okay. Now, tell. Second question, class. The rectangle is placed. I will tell you how it is placed. This is O. The rectangle is placed so that the point A correctly touches A, O. That is, or you can tell rectangle is placed inside. See, the rectangle is placed in this quadrant, inside here, in between, with AD touching OY and AB touching OX, or simple language, point A touches O, means it is how it is, see, 250 by 400, see here, this way. Okay, right here, this is 250 outside, I will put dimension outside, 400. Now, your centroid is, see, this is centroid G. Centroid G. Start. Now, I about any axis. Okay. Start. First, I about OX axis. Come to centroid. Axis passing through centroid parallel to OX. Oh, this axis. See, you write here. What axis is you drawing now? I about this axis first. Parallel side 250. 250 into 400 cube by 12. Oh, same. This will remain same throughout today. Plus area. 250 into 400 area. Into, see, axis is, I will tell last time now. Next I will not tell. Axis horizontal means distance vertical. Last warning. Axis vertical means distance horizontal. Next time I won't tell. So, perpendicular distance from centroid to the required axis is, see, this distance square. So from centroid G to OX, this distance exactly, see, this is 400 means 400 by 2. It is 400 by 2 whole square over. Red color. H is red color. This will keep on changing. 400 by 2 whole square. Answer not required. Okay, now I about OY. See what I am doing. Remove this one. You take a pencil. Okay, see. Now do one thing. Use pencil every time. I about an axis passing through centroid and parallel to required axis. Oh, now parallel side is 400. 400 into 250 cube by 12 plus area 400 into 250 into from centroid of the component to YY axis. See, I'll put red color now if you want. This distance square. Okay, red color. Last time was red color. This distance square, red color. That distance is half of 250. 250 by 2 whole square. You get I about OY. Okay, now next question number 3. I should remember question number. I'll keep on changing here. Question number here 3. Class. This I will remove. See, this arrangement. See, everything you have to write and do it. Okay, this I can keep on changing. Okay, right. Question number 3. I will tell how is the arrangement now. Okay, this is O is troubling me. O here. Okay. The rectangle is placed symmetrically with respect to OY. Means, see, this way I told, symmetrically with respect to OY, but with bottom edge AB touching OX axis. See, bottom edge AB touching OX axis means, see, this way. See here, A, B, C, D. I told symmetrically with respect to OY with the bottom edge AB touching OX axis. So now this is how much? See, this is 250. They told symmetrically placed with respect to OY. Therefore, both these are how much? 125, 125. Whereas this is 400. Okay, now start. It's centroid G, mark first, green color. Centroid G is here. Centroid G here. Start. I about OX axis. First come here. Axis passing through centroid parallel to OX. This axis. That is 250 into 400 cube by 12. Why I won't explain. Area over into, see, this distance square. See which one? See now, red color. Into from center. See, last time I am telling, axis is horizontal means distance vertical. Really last time. Axis vertical means distance horizontal, or perpendicular distance from centroid to OX axis means, see, this distance. That distance is once again 400 by 2. Okay, same as last time answer. Now come to I about OY. What to do? Remove it. Everything remove. Pencil mark. Actually, not by practicing. Repeatedly going through this class will give you complete control. One fine day you will tell, now 100% clear. Okay, see, that. Axis passing through centroid parallel to YY. Oh, same axis here. I about its own axis. 400 into 250 cube by 12 area into from centroid G to OY perpendicular square. No, centroid G lies in OY, therefore 0 square. Therefore it is 0 square over. This is 3. Now I will come to 4. 4. Statement you are right. Okay, see what I am doing now. Oh, okay. Oh, okay, now 4th question. The rectangle is placed symmetrical with respect to x-axis, OX-axis. Symmetrical with respect to OX-axis. But see, I told last time, symmetrical with the OY-axis, AB touches what? OX-axis. Now, symmetrically with respect to OY-axis and AB touches OX-axis. Symmetrically, AD axis, not axis, AD touches OY axis. See here, this way. This way. I told symmetrically with respect to, no, this is not symmetrical with respect to this. Last time how I placed, I forgot it now. Just now I placed, I forgot it now. See, IOX I got 250 square, means this way. Okay, this way. And now I want this, see here. This way. Okay, no problem. I will change it, no, don't worry. See, there may be confusion for question number for me. This way, see here. See, correct, clear. 250 here, out of scale. 400 here. I told you one thing now, question is symmetrically with respect to OX axis. Therefore, each of them is 200, 200. See, I told symmetrical with respect to which one? With respect to OX axis. And then right here, AD touches OY axis. See, AD touches OY axis. It touches here. See, this side AD. This side AD touches OY axis and symmetrically with this, or you can write here as shown in figure. Okay, now start. Now centroid will be here, green color. See, its centroid is here, G. Start. I about x axis, OX axis, not x axis, OX. First come to axis passing through CG, see, parallel here, this axis. I about this axis, 250 into 400 cube by 12. Next time I won't tell. Area over into perpendicular distance from centroid to, not there, 0 square. This is 0 square. 0 square. Come to I about OY axis. First, I about its own axis. See here. Its own axis. How much? 400 into 250 cube by 12. Plus area into perpendicular distance from centroid to OY axis. See, this distance square. That is 250 by 2. 250 by 2 whole square. 250 by 2 whole square will give I about OX and OY. 4 over. Now fifth one. Take a little rest actually. What I will decide next cases. Actually earlier there are 3 lights here. One of the light I forgot to switch on. So now you can see screen little bright. Okay, no problem. Fifth question, class. The rectangle is placed, see, where AB touches OX axis. See, this AB bottom edge touches OX axis and see, this is 250 by 400 and I told this AB touches which one? OX axis, but from the OY axis it is not symmetrical. 100 mm is to left side and remaining to right side. See, I told 250 here, 1 minute now. It is told 100 mm to left of Y. See, this width here, whatever 250 is there, you write there. The width 250, 100 mm lies to left of OY. See, 100 mm lies to left of OY. Okay, write the question. So, if that is 100, this is 150. It is, see, 100 is given in the question. From 250 subtract 100, this will be 150. Okay, now centroid. See, This way 400 means midpoint. This way this is 250, half of 250 is 75. So centroid will come here. Now start. I about its own axis. First I am telling IOX, own axis. 250 into 400 cube by 12 plus area into, see, when you want I about OX square from centroid, see, we want I about OX from centroid to OX. This distance square is exactly 400 by 2 square. 400 by 2 square. 400 by 2 square. Okay, that's important. Next, come to, I'll remove this one now. Come to I about OY. First consider axis passing through centroid and parallel to YY. See, it is this axis. This axis. Parallel side is 400. So this is clear. Plus area into, see now, it is what? From centroid to OY, this distance square. That distance is 150 is this width. This is 250. If this is 250, from here to here is, see, this is, don't see there. This is 250. If this is 250, from here to centroid is 250 by 2. So from 150, subtract 250 by 2. See, this all you should understand. From 150, subtract 250 by 2. Or you can do one thing. See, if this is 250, this is how much? 250 by 2. From 250 by 2, subtract 100. Both are same. Whatever you want. That square will give I about OY. Next. Next I will give sixth question now. Sixth question. I'll now touching this one. Okay, now I'll put here. Now it will touch here. See. Now what I will do is, see, this all to understand correctly concept, because later when you do moment of inertia, all these cases will come. This I am doing only for rectangle, remember. Your rectangle, right here, this rectangle, AD edge touches OY. Touches OY. See, touches OY. And see, it will come this way. Now what I will do is I will put somewhere here. Last time touching which one? OX, now OY. See. Okay, this way. See, it's bigger to understand correctly. This way, okay. Touches OY. Out of scale, okay, bigger I'll make, okay. Now, okay, see. This is how much? This is 250. I told you this, see, this is a rectangle. This AD edge touches OY and, oh, sorry, some little portion this side required. Okay. Otherwise it will become same as last time. 1 minute. Here, is it same as last time by chance? Is it same as last time? I about OX is it same as last time? Getting little confused now. Which case over? I'll check once again. Last time video resume. Now write the sixth case. Now light is little more bright. Okay. Question, sixth class. How it is placed is your side AD touches OY. Side AD touches OY. OY. See, 400 touches OY. And the width and depth wise, and of the 400 depth, 140 mm of the depth is above OX. I told 140 mm of the depth is above OX. See, AD touches OY. See here, correctly touches OY. And of the depth of 400, 140 is above OX. So if that is 140, surely From 400, subtract 140, this will be 260. Given calculated value. This is we calculated, 260. 260. Okay, over. See, now, this is centroid. See, centroid G. This way midpoint. This way total is 400. So this is 200 and 200. Okay, start. I about OX. When you do I about OX, see here, OX, first come to I about its own axis. 250 into 400 cube by 12 plus area into, see now it is this distance square. That distance is 260 minus half of 400. That much should be clear for you by this time. It is 260 minus 400 by 2. See here, this is 260. This is 400. So center is, this is 400 by 2. This square. Or you can do one thing. You can do, see, this is 400. This is 400 by 2. From 400 by 2, subtract 140. Both are same. You can write there. Or you can write 400 by 2 minus 140 whole square. Okay, over. I about OY. Start. Remove this one. All pencil mark. See. First I about its own axis. See. Its own axis is here. As usual, 400 into 250 cube by 12 plus area into from centroid to OY this distance square. That distance square is how much? 250 midpoint 250 by 2 whole square. See, 250 by 2 whole square. This is your question number 6. Now we'll go to question number 7. Now it's interesting. See, question 7 is very, very important. More concept is there. Question 7. I'll first place it, then give the question. I'll first place it, then give the question. This is O. What I will do is, I will place the rectangle, see, here. This way, I will place the rectangle. See now, correctly. This is 400. Question I will give later. This is 400. Somewhere outside right here. This full is 250. Okay. Now, the rectangle is placed so that width-wise 250 is there. 90 mm is to right side of 90 mm given in the question. 90 mm of the rectangle is to right of OY. So, see, 90 mm is to right of OY. See, rectangle is here. 90 mm should be right side. Okay, if that is 90, surely you can calculate this one. From 250, subtract 90, 260. 160. This will be 160. Calculated value. Okay, then. And depth-wise, this is 400. See, 400, a part of it, 115 mm is above OX axis. Of 400 depth here, 115 is above OX. So if that is 115, this is total 400. This is 285. How? From 400 subtract. Okay, now see centroid. See, 250 by 2. So this is O point, be careful. This is your O. Centroid marking, 250. 250 by 2 is somewhere here. 400 by 2, centroid will be here. See, this is centroid for the rectangle. Centroid. Okay, start. Remember, 250 by 2, 250 by 2, 400 by 2, see, 400 by 2, 400 by 2. So, I about XX, OX. First, as usual, BD cube by 12 over, plus area over, into, when you want I about XX, see, it is red color, this distance square. That distance is equal to 285 minus half of 400. You should write everything. 285 minus half of 400. Or right there, or other alternative. See, when this is 400, from centroid to here is how much? 400 by 2. 400, see, we want this distance. 400 by 2 minus 115. You should write there, or 400 by 2 minus 115 whole square. Okay. I about OY. Start. First, remove this one. I about its own axis. 400 into 250 cube by 12 plus area into, now see, now it is this distance square. From centroid to OY, this distance square is, if I see here, this is 160, this is 250 means, this is how much? From centroid to here is what? This is 250, see this is 160, centroid is here. When this is 250, this is 125, 250 by 2. So 160 minus 250 by 2 whole square. 160 minus 250 by 2 whole square, or you can do one thing, write that side. See, this is 250. This is centroid is at what? 250 by 2. You either write 160 minus 250 by 2 whole square, or 250 by 2 minus 90 whole square. You write both of them to understand. You get the answer. Okay, now major part is over. Now I changed question. I think I changed question number. I forgot. By chance, if I change the number, you put A and B. Okay, 8. 8. Still lot are there. 8. This I remove. Now becoming easier. See, these all I am giving so that later when you find moment of inertia, there is no problem for you. O, X, Y. Okay. Next one. 8th one. See, the rectangle is placed so that, see, it side AD touches OY. Side AD touches OY. See here, side AD touches OY. See, this AD side touches OY, and the rectangle is placed, it is given in the question, is placed at some 130 mm above OX axis. Above OX axis 130. This is rectangle is placed, see, you should write here, rectangle is placed above OX by 130, and so that AD touches this line. Okay, start. Now it is very simple. See, centroid is here, G. Start. I about OX axis, its own axis here. I forgot to write enter dimensions here. Okay, right here. This is 250, somewhere here 400. Okay. As usual, this I don't have to explain. 250 into 400 cube by 12 plus area into from centroid to OX. See, now it is from centroid to OX, this distance square. That is 130 plus half of 400. (130 plus 400 by 2 whole square). Okay. Tell I about OY axis. First, remove this one. I about its own axis, its own centroid axis, this axis. 400 into 250 cube by 12 plus area into, now you require this distance square. That distance is 250 by 2 directly. 250 by 2 whole square. 250 by 2 whole square over. You get IYY. Now, question number 9. 9 is, see, the rectangle is placed above OX. I'll put somewhere here rectangle dimension. 250 rectangle dimension where space is there. Overall dimension 400. Okay. 250 is there. 110. 110. This is shifted now. 110 is anything. Randomly 180. Okay. The rectangle is placed above OX by 180 and widthwise of the width of 250, 110 mm is to right of OY. See, 110 width, or finally as given in the sketch you can write. If that is 110, this will be, see, 250 minus 110 is 160. Oh, sorry, not 160, 140. Okay, okay. 140, calculated value. Okay. Calculated value, start. Centroid, see where is centroid now? See, depth-wise center. But width-wise, this is 250, half of 250, that is eccentric now. See, half of 250, centroid here, G. Start. I about OX axis. First about its own axis. 250 into 400 cube by 12 plus area into, see, with distance from centroid to OX, this distance square is 180 plus half of 400. (180 plus half of 400). Now, I about OY axis. First about, see, its own YY. See here, its own YY, somewhere here. 400 into 250 cube by 12 plus area into, see, from centroid to OY, this distance square is, this is 140, this is 250 means centroid to here is half of 250, 125, 140 minus 250 by 2 whole square. 140 minus 250 by 2 whole square, or right here, or other alternative. This is 250. See, this is from here to here is 250 by 2. 250 by 2 minus 110. Or you write here 250 by 2 minus 110. See, first time 250 by 2 is negative sign, subtracting. Now from 250 by 2 subtract. Okay, over. Now over. Last 3 more cases. 9, 10. 10. It's almost over. The rectangle is placed, see, OX, OY, O, with AB, bottom edge AB touches OX. See, I am covering each and everything. OX. Bottom edge AB touches OX and, see, bottom edge, I told AB touches OX and this already over. No, not already, and touching already, it's already over. And height wise, okay, height wise, see, change, it's already over. Then, no, here only same. Okay, leave it. If it is over, no problem. One more. 250 and this is 400. Okay, if it is over, take one more case, no problem. And height wise, 400 is entire bottom edge touches OX, and see, width wise, the rectangle is placed at some distance here. See, some distance here. Now above, yes, correct. Some distance. Say how much? 90 mm. So rectangle is placed at 90 mm to right of OX and bottom edge touches OX. Suppose it's already over, no problem. One more extra. Start. Finish fast now. Centroid G here. Now I'll do fast now. See, I about OX axis. First about its own axis. Same answer, same answer. Distance square is from centroid to 2ox. See, this distance square is 400 by 2 whole square. 400 by 2 whole square. And when you want I about OY axis, see first I about its own axis here, 400 into 250 cube by 12 plus area into, see, from centroid G to OY, this distance square is 90 plus 250 by 2. It should be crystal clear by this time. 90 plus 250 by 2 whole square. See, centroid. Okay. 10 over 11. 11, what I will do is, I will slightly shift it down now. See. Over. Last case. Then one more case. Question is over. OX. The rectangle is placed, see, this way. Okay, now correct. This is O. Rectangle is placed to right side at 75 mm to right of OX. See, rectangle is placed at 75 right of OX and 400 depth is there. Say around 85 mm depth of the rectangle, not 85, little more. This is 125, okay, 85. And 85 mm of the depth of rectangle is above OX. See, of the full depth of 400, 85 is above OX and remaining below. How much below remaining? Remaining below will be 250 minus 85 is 170 into 165, correct? That also doubt nowadays, see. What is 165 plus 85? 0, correct. Okay. Not 165, sorry. It is not 165. Oh, too much depending on calculator. I don't know why human people are spoiled by this calculator. 400 minus 85 is 400 minus 85 is 315. I don't know why I am doing it. Okay. 315. Not given calculated value. Okay, this is 250. 250. Depth where I will mark? I will mark here depth. X is here. See, some space required to mark the depth independently. Total depth I will mark here. Total depth is 400. I told question, rectangle is placed at 75 mm to right of OY and of the 400 depth, 85 depth is above OX axis. Okay, over. Start. I about OX axis. When you do I about OX axis, see, centroid first here. G. First about its own axis. 250 into 400 cube by 12 plus area into, see, correctly observe now, this distance square. That is two options for you. One of the option, from 315 subtract half of 400. One of the option. You should write both of them. From 315 subtract half of 400 whole square. Or, see, this is 400. Centroid to here is 400 by 2. From 400 by 2 subtract 85, right there. From 400 by 2 subtract 85. Write both the options. Okay. I about OY. First this axis. First about its own axis. As usual, 400 into 250 cube by 12 plus area into, see, from centroid to OY, see, centroid to OY is this distance square is 75 plus half of 250 plus 250 by 2 over. This is also over. So 11 over, lastly 12th one, closing part, 12th one. Closing part. These are all given so that you understand each and everything later. See, today it is a rectangle. Later, this G can be for triangle, semicircle, that time I'll explain. So now see, once again, last question, 12. Now it's a very easy question. Go, x, y. This rectangle is placed somewhere here. Okay, now there is no confusion because clear, see, somewhere here. So that it is placed on the 140 mm above OX and 250, 125 mm, 135 mm to right of OY. See, the rectangle is placed 140 mm above OX. So a rectangle starts at 140 above, and this way the rectangle is placed at 135 right, or finally right as shown in the figure. Okay. Once again, this is the easiest one. See, 250 by 400. Over. Centroid mark first. Centroid G here. Okay, start. First I about OX axis. First about its own axis. 250 into 400 cube by 12 plus area into, see, from centroid to OX, this distance square, that is 140 plus 400 by 2. 140 plus 400 by 2 whole square. You get the answer. Then I about OY. First I about its own axis. See here, this axis. As usual, 400 into 250 cube by 12 plus area into from centroid to OY. See, this distance square. Perpendicular, no space to mark here, from here to here, perpendicular square. See, anywhere you can mark perpendicular square. Horizontal distance is 135 plus half of 250. 250 by 2 whole square. Okay, this will complete rectangle. Now I will tell you something. You should correctly observe the small g. Next class, all I am placing like this. The touching the axle, I am not doing it. There is a limit for everything. If I do that way, 30-40 hours are required. As it comes later, we will consider it. So, for what's important is how to decide H last term. This H should be red color. See, H is red color. Okay. How to decide that H is the most important. For that, what you have to do? You have to observe, irrespective of rectangle, triangle, anything. What you do? See the centroid of the component. See where is centroid of the component. If you want I about OX square, it is this square. If you want I about OY, it is this square. That's all you require. So go through this example thoroughly, fully practice and get ready. Next time what I will do is, see, next time I will do one thing. I will place first, see, 12, question 12 over now, triangle, see, this triangle. Okay, as it is over, this triangle. When it is over, this way. When it's over, I will change it. See, one triangle this way, one triangle this way, one triangle this way, one triangle this way. Then one circle, one isosceles triangle. This way, this way, this way, and this way. 4 random triangles. Then circle. Then 4 times what? Semicircle. Same way, 4 times quadrant. That all, I single class I will finish because for all the questions, I will place it somewhere here. Touching the axis concept you should learn. See, when the area cuts the axis, that you should learn from rectangle. That small detail, how much this side, how much that side. It will come later. When you do moment of inertia calculation, it will keep on coming. So basic concept, refer rectangle. And thorough practice of different shapes, consider triangle. Right angle triangle, 4 cases, isosceles triangle 4 cases, then triangle in general 4 cases, 1 circle, 4 semicircles and 4 quadrants. That all will be in your part 5. Okay. Once part 5, that is next class. Once part 5 is over, then I will tell, yes, now we are ready to start non-stop problems of moment of inertia. Angle, I section, T section, L section, then so many one by one built up sections, sometime with the semicircles, quadrants, some portion cut out, then built up sections, or sometimes people call compound sections, all will cover. So for understanding, see, no one will tell you so many cases for rectangle. They will tell BDQ by 12 plus A square over. No, you understand all the concepts. Okay, thank you. We'll meet in the next class.